Hi guys, so today I'll tell you about a project in which what we are doing is we are like creating a web server in which there is a form of taking two inputs A and B. Now what that form is doing is it takes two input and there's a submit button in the form. What when you click on submit, there will be few operations performing by EC2 servers on AWS. So what those servers are doing, one server is there to perform addition, then one for subtraction, one for multiplication, one for division, and then all the results are gonna send back to you on your web server when you click on submit. But then if supposedly you have a huge workload or like a huge, there are so many people doing on it, then the EC2 will take time on performing the operations. So that, so now what is happening is now we have three sets as of now for the input. Now what those three set is, now once you click on the submit button by taking input A and B, it will be sent to the first set of EC2 instances of performing all the operations and all. Now, when the you click on second, the second set will be free as of now because the first set is already performing. So the second set will be performing the operation. Then now the two sets will be performing the operation. If you click on the command for the third time, then it will be for the third set. So this is how the inputs have been distributed to host whichever EC2 instance that is being free. So right now the first instance is working, then the next command is sent to the second, then for the third, and then simultaneously there are other EC2 instances like there are three for input, three for addition, three for subtraction, multiplication, and three for division. And such that all those instances are working all together. Now, how all those are working together is once you once you perform a first operation, it'll be sent to the first set of set of EC2 instances to perform. Then the second time you perform the operation, it'll be sent to the second. So that I have written a set one, set two, set three, so that you'll get to know that there is not only single EC2 that is performing the addition. There are three EC2 instances that are performing addition, three for multiplication, subtraction, and such that. So let's just go to our code and see how we have done it. So again, we are using Terraform to uh, performing all the resources like to initiating our AWS resources or uh, making our AWS resources. We are using Terraform. Right now, this is my Terraform script to like this perform all the operations, and the scripts have been written in the EC2 user data. Now let's just go and let me show you. So we have provided the region and the access key and the secret key so that AWS Terraform will know in which AWS we want to create it. Now in the resources, first is Flask app. The web server which we are making, we have given it the name as Flask app. Now this is the AMI ID for Linux server, and there is this security group and wizard uh, launch wizard 2, which means this security group is already there in the EC2, and it has inbound rules to uh, take traffic all from port 5000 from anywhere and send traffic to port 5000 from anywhere. So that is what the security group is. And the key is you can make your own key if you want to, and the name we have given it as Flash distribution. Now we have made the EC2 instances in such a way that set one EC2 instances will be like 1A, 1B, 1C, 1D. 1A will be addition, subtraction, multiplication, division. Then 2A for addition, multiplication, and like that. So right now we have given a EC2 instance which is named as 1A. Now 1A is the name, and inside I have written nothing but the uh, result, which will be taking the input of two number from the web server. I'll let you know how we perform the web server task, and then return number one plus number two, like addition of two number. Then similarly, 2A will be performing the same operation, and there will be third instance that will be performing the same operation. So everything will remain same. Just I have written the name is different, like 1A, 2A, 3A. Now there will be 1B. like the EC2 instance 1B, what it is doing is performing the subtraction. Then there is 2B that is performing the subtraction. Then EC2 instance is how you make your EC2 instance. Everything is same, even the script is same. It is fetching the number from Flask server, num1, num2, and then returning the result as num1 minus num2. So this is for 3B. So these three instances are performing subtraction. Now three instances are going to perform multiplication, like 1C, then 2C, then 3C. Then three instances are performing multiplication. You could see here they are returning the result as num1 into num2. Then three instances are performing division, like num1 slash num. So 1D, 2D, 3D are the name of those instances. It's just we have initiated all the instances separately, just that you'll be able to see that we have built three instances for addition, three for subtraction, three for multiplication, three for division. Now this is what we have done. Now all the data that we are storing, we are gonna create three DynamoDB table to store the data. One table would be just to store all the data that is there, uh, perform whatever operations are performing by whichever set, all the data is being stored in the DynamoDB table. Now the two other Dynamo table we have created will show you. So this is the DynamoDB table. So right now what we are creating is DynamoDB table 1, DB table 2, DB2, and DB3. So these are three DynamoDB table that we are creating using Terraform. So resource is AWS DynamoDB table, name in local. Now name on the AWS will be like this. And paper request is the billing mode. How much you're gonna transfer the data is how much you're gonna pay for it. And apart from this, now what the other two DynamoDB table is doing is one is storing all the data from instances. Till the other two, firstly let's just quickly these are the code that we have saved it. Let's just run this till then, and I'll tell you documents. This is my folder on your terminal. Let's just go Terraform plan. Now it will run our plan. It'll give us a structured layout of whatever we are gonna perform. I'll tell you the other two DynamoDB tables are uh, Terraform apply. What those other two tables are doing is one table is fetching the results. Both the tables are used to read the data from those main DynamoDB table. First Dynamo table is the main DynamoDB table. Now the other two are fetching the results from it. Supposedly you want addition and subtraction results only. So the other two are uh, the second table will be performing the operation to take all the data just of the addition and subtraction. Now you want the other table to be performing. Those other two are performing read. Now if you want to read something from the first table, you're gonna take now you want key. I want only multiplication division data. So what you can do is you can just uh, take the help of third DynamoDB table and fetch the data from the main DynamoDB table and just let us know that uh, that it will show only the table data of multiplication divide, and just like that you could do as per if you want addition subtraction addition multiplication only. So now that we have created, now you could say what all things are created is I'll show you here. So right now you could see 1A 1B dynamo table 1 2 3 1 2 is created, 1A 1B 1 2, like these are uh, 12 instances are creating. So all those things now I'll show you it here. And now you could see here. Now all these instances are currently running. Now you need to run Flask server on each and every instance. So let's just go to our, I'll just show you. Let's go to our instance 1A, copy the IP address, just clear this, and just SSH into our instance 1. I'll SSH into my 1A instance. Yes, now ls. Now you can see instance 1a.py is the file here. So I'll just run this Python 3 instance 1a.py. Now this server is running. Leave it like that. Now go to our 1b server. Let's just go to our This is the 1B. Let's just run Flask server on this. SSH into this. Now, yes. Now you'll be able to see there is a ls. You could see instance 1B file. Now you could just run this Flask server, and this is Python 3, Python 3 instance 1B dot py. This is the this will run the Flask server on this. Now let's just run on 1C. Now we'll run it on 1C. Now SSH into 1C. And similarly, you have to run Flask server on each and every instance. So you do SSH, now you do ls, now the name of file, now you run Python 3, python, Python 3, and the file name instance 1c dot python py. So it will run the Flask server. Now 1D. Now let's just go and SSH into 1D. Now yes. Oh, okay, I did mistake. Terminate. Just go to 1D again. Yes, yes. I would say ls. Now Python 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 3 instance 1D dot py. Now you could see I've run a command on 1D as well. Now I'll show you the our Flask server code. Now this is the Flask server code. Now these are different three for each. Now we are gonna add the URL of each server so that it could send it to whoever is free. Now once the request is sent, it will send the request to whichever Flask server is free. Now how we are gonna do is first let's just edit off all the uh, let's just edit all the URLs. Public IPv4 address, I mean. Now 1A will change this to 1A. Then after that, let's go to 1B, copy 1B, and just edit it here as 1B. Now go to 1C, and then you'll edit it as. Now 1C is for multiplication. All the C1s are for multiplication, D is for division. Now let's go to 1D. Now 1D, D is division. Now quickly remove the IPv4 address and change to the recent IPv4 address. Now, similarly, you have to add for all the other things. So now you see I have done this thing. I've added all the URLs, edited for all the running instances and run all the servers. Now I'll go and run my Flask server. Now this is my Flask server. I'll just run this. Now SSH into my Flask server. Now, yes, I'll have to do everything. So it will be sudo update by, oh, so sudo yum update by, and sudo yum install python 3 pip, 3 pip. Now you're gonna install pip3 install flask boto 3 qust requests. Yeah, now flask is and everything is getting installed. I'll just clear the screen. Now you could see ls there is no file. Now we're gonna nano Flask app dot py, and the file which we have saved here. Copy this. You want, you could see I'm writing the same things from Flask, import, import Flask, array QUST request, and import array QUST requests, then import boto3, then import UUID. UUID just to give different names to our DynamoDB table operation. Every name has to be unique, so that's why. Copy, and you go to the terminal, you paste here. Now you save this. Yes, Control X. Now you just run this. Agent Python 3 Flask app.py. Now this Flask app is running. Now everything is running here. Now you could see, let's just copy this and just paste it here. We're running it on port 5000. Now we enter. So this is our form right now that you could see. Now I'll just enter 10 and 2 as the first number. I press on submit. Now I get the results from set 1. Set 1 was 1A, 1B, 1C, 1D. These are the results. Addition, subtraction. Now I go back. Now I click 20, 10. Now I click again. Now you see earlier we got the results from set 1. Now it's from set 2. Now 1B, 2A, 2B, 2C, 2D instances were on work. Now again, if I go back and click 30 and 20 and 20 and click on submit, you see now the set 3. Now the third set like 3A, 3B, 3B, C instances were currently working. Now what is happening right now is, now you could see right now what is happening is, now everything is currently working here. But I'll also show you here. It just DynamoDB table, and now you see there are three tables you could see here. Now there are three tables. Now all the tables have been right now uh here. DynamoDB three table. You could see read capacity were consumed and everything. Now you go back to your here this. Now what is happening right now is, this is was the complete project. Now what has happened right now is, what has happened is, now your first time you took the input, it was being run by the first server, the first set of EC2 instances, 1A, 1B, 1C, 1D. Second time, 2A, 2B, 2C, 2D. Third time, it was by the third server. Now, why we have done so many services? If now this is what scaling as of now is. Now, if you have a load on this EC2 server, now if you have only one server running in your background, then all the load will be happening to that. But now, if you are now you have three servers for each operation running in the background. So what does that mean is, now you have, even though you could see right now, if anybody else is gonna perform action, it will be directed to those EC2 instances which are currently free. Now, the last working instance was supposedly one. Now, somebody else perform an operation. Now, it will be given to either two or three, because earlier one was in use. Now, two or three are free. So, two or three will be currently, and all these data is being stored in the DynamoDB table. And by DynamoDB table, I mean right now, uh, you could go on our this is now the Flask server apps. Now what is it doing is, this is performing all the operations on each EC2 instances by round robin technique. It is giving it to whoever is free. Now saving the DynamoDB table. Now this is the, by using Boto3. Now what is happening is, DynamoDB table is taking the resource from AWS in the US East 1 region. The table will be DB1. Now we have created three table. DB1 was the main table. Now once the results are out, now the now here it is performing actions and taking the input. Now, this is the submit button. Now, what is happening is, you submit num1, then to num to enter, and then once you submit it, It has gone to whichever EC2 instance which was free. And now what is happening is it is saving all the results coming from those EC2 instances to our DynamoDB table using this method function. Now we have made this function in such a way that in our DynamoDB table, there will be three things, three columns, num1, num2, and num result. So num1 will be storing the integers in num1, num2 will be storing it in num2, and the results will be storing in there. Now, if you want something, now this is our second, where in which now in this, what we have done is there are the two other tables, DB2 and DB3. Now, what these two tables are doing, supposedly, now I have assigned the action of giving if you ask DB2 to give us the answers, like give us the tables, then it will give us the tables according to addition and subtraction. Now, if you ask DB3, it will give us the tables for multiplication and division. So this is the way the other two tables are reading the data from the main table, DynamoDB table. Now you'll again see, you'll again like 10, 20, and we'll submit. Now you'll see set one. Now you go back, you perform the same task, Control C somewhere here. Now you'll see just 23 and 2. Now, earlier it was done by set 2, and now it is being set 3. Now, someone else in his computer will do it will be given to those who now, if you will perform it in your computer, then what will happen is it will assign the task to perform the operation to whichever EC2 instance which is free. So, so this is the way that you have assigned. um scaling to a EC2 instance as well as storing the data to your DynamoDB table. Now, here are the three DynamoDB tables that you have stored. Now, these are the three Dynamo tables that you want to store. The you could see on demand is the reading on demand, and everything is on demand. What it means is the pricing for this DynamoDB table will be on demand. So, how many data you will be transfer is the then it depends on the data you transfer and add to the DynamoDB table. The pricing will be set accordingly. Now this was the project which we completed right now. Now if you want everything, I have added everything to my GitHub. Now you could see on my GitHub I've added everything for the codes and everything if you need for your references.